Hello and welcome back to the Quality Excellence channel. I'm Mayank Agarwal, and today we're moving into Chapter 19 of our Lean Six Sigma training, Correlation and Regression. This is a crucial chapter for anyone looking to truly master data analysis and process improvement. We're going to equip you with the knowledge to not only understand these concepts, but also apply them effectively in real-world scenarios. Today we're exploring two powerful tools, correlation and regression. These aren't just abstract statistical concepts. They are practical methods that can unlock valuable insights from your data. They help us understand relationships between different variables and make informed predictions based on those relationships. Correlation and regression. We'll start by defining each of these terms, exploring their underlying principles, and then demonstrating how they can be used to solve real-world problems. Get ready to delve into the world of data and discover how these tools can transform the way you analyze and interpret information. Think about how studying more often leads to better grades. The more time you dedicate to studying, the higher your chances of achieving academic success. This is a classic example of a positive correlation, where an increase in one variable, studying time, is associated with an increase in another variable, grades. Or how ice cream sales rise on hot days. As the temperature soars, so does the demand for this sweet treat. This is another clear illustration of correlation, showing how external factors like weather can directly influence consumer behavior and sales patterns. These are patterns we can analyze with statistics. By using statistical methods, we can quantify the strength and direction of these relationships, providing us with a deeper understanding of the underlying dynamics at play. Correlation and regression help anyone, not just scientists, but also business professionals, marketers, and decision-makers across various industries. These tools provide a framework for understanding complex relationships and making data-driven decisions. Make smarter, evidence-based decisions. Instead of relying on gut feelings or intuition, you can use data to guide your choices and improve your outcomes. This leads to more effective strategies and better results. In Six Sigma's analyze phase, these tools help you find which factors truly impact your process. By identifying the key drivers of variation and performance, you can focus your efforts on the areas that will have the greatest impact on your overall goals. We'll break down these concepts with simple examples, using clear and concise explanations to make them accessible to everyone. No prior statistical knowledge is required. We'll guide you through the process step by step, so you can spot and use patterns in your own data. You'll learn how to identify correlations and build regression models using readily available tools like spreadsheets, empowering you to analyze your own data and extract meaningful insights. First, we'll look at correlation, how two things move together. We'll explore different types of correlations, including positive, negative, and zero correlations, and learn how to interpret correlation coefficients. Then we'll dive into regression, which lets us model and predict outcomes. We'll focus on linear regression, a widely used technique for building predictive models, and learn how to assess the accuracy and reliability of our predictions. By the end of this chapter, you'll have a solid foundation in correlation and regression, and be ready to apply these powerful tools to your own data analysis projects. In the world of data analysis, understanding relationships between different sets of information is crucial. One of the fundamental concepts that helps us achieve this understanding is correlation. Correlation measures how two variables move together. It's a statistical technique that tells us whether two variables are related and how strongly they are associated. Are they moving in sync, or are they moving in opposite directions? The correlation coefficient, often denoted as R, is a key metric in quantifying this relationship. This coefficient ranges from -1 to +1, providing a standardized measure of the strength and direction of the correlation. Think of it as a scale that tells us how closely two variables are intertwined. It shows both the strength and the direction of the relationship. A value close to +1 indicates a strong positive correlation. A value close to -1 indicates a strong negative correlation, and a value close to 0 suggests little to no correlation. Positive correlation means that as one variable increases, so does the other. They move in the same direction. A classic example is the relationship between hours exercised and calories burned. Generally, the more you exercise, the more calories you burn. Negative correlation, on the other hand, means that as one variable goes up, the other goes down. They move in opposite directions. Think about the relationship between car age and resale value. As a car gets older, its resale value typically decreases. No correlation implies that the two variables move independently of each other. There's no discernible pattern or relationship between them. For instance, there's likely no correlation between coffee consumption and height. One doesn't influence the other in any predictable way. A scatterplot is an invaluable tool for visualizing these relationships. By plotting data points on a graph, we can quickly identify potential correlations. However, it's crucial to remember that correlation shows a relationship, but it does not prove causation. This is a critical distinction to understand. Just because two things move together or appear related doesn't automatically mean that one causes the other. There might be other underlying factors at play, or the relationship could simply be coincidental. Therefore, always look deeper, investigate further, and consider other possible explanations before drawing definitive conclusions about cause and effect. Now, let's delve into some real-world examples to see how the concept of correlation works in practice and how it can be applied in various fields. Regression goes beyond correlation by modeling the relationship between variables. Simple linear regression uses one independent variable, x, to predict a dependent variable, y, with a straight line. Y equals sign b0 plus b1x. The slope, b1, tells us how much y changes for each unit increase in x. Multiple regression includes several independent variables to predict y. For example, a student's score might depend on hours studied, previous scores, and sleep. Key outputs, R² shows how well the model explains the data. P-values test if variables matter. Coefficients quantify each variable's impact. Regression helps you make predictions and understand what drives results. Within the structured framework of Six Sigma, the analyze phase stands as a critical juncture. It's where we transition from simply observing the problem to truly understanding its underlying mechanisms. This phase is all about digging deep, identifying the root causes that contribute to process variation and inefficiencies. And two powerful tools that can be leveraged in this phase are correlation and regression analysis. These statistical techniques provide invaluable insights, helping you to not only identify potential root causes, but also to quantify the relationships between different variables. They allow us to move beyond intuition and make data-driven decisions. To illustrate this, let's consider the example of a logistics company. This company is struggling with consistent on-time delivery performance. They're facing customer dissatisfaction and increased operational costs due to these delays. The management team knows there's a problem, but they need to pinpoint the exact factors contributing to it. This is where correlation analysis comes into play. By examining the relationships between various factors and delivery times, correlation analysis might reveal that cargo weight and route distance are significantly linked to delays, indicating a strong positive correlation. This means that as cargo weight and route distance increase, delivery times tend to increase as well. However, the analysis might also show that truck age doesn't have a statistically significant impact on delivery times. In other words, truck age isn't. With these insights, the team can now focus on the key variables that have a real impact on delivery times. They then build a regression model, which might look something like this. Delivery time equals sign 2.5 plus 0.05x. Cargo weight plus 0.15x route distance. This equation quantifies the relationship between the independent variables, cargo weight and route distance, and the dependent variable, delivery time. Now, armed with this model, they can predict, with a reasonable degree of accuracy, how changes in cargo weight or route distance will likely affect delivery time. This predictive capability is incredibly valuable for planning and decision-making. This data-driven approach allows the logistics company to target the real causes of the delays, instead of relying on guesswork or intuition. And with clear, quantifiable evidence, the team can confidently move forward with targeted solutions, such as optimizing delivery routes or implementing weight restrictions. That's the power of correlation and regression analysis in process improvement, enabling data-driven decisions and leading to tangible, positive results. Don't confuse correlation with causation. Ice cream sales and drowning both rise in summer, but one doesn't cause the other. Always visualize your data. Regression assumes a straight-line relationship, but real data may be curved or have outliers. Outliers can distort results, so investigate them. Avoid overfitting by keeping your model simple. Too many variables can make predictions unreliable. Don't extrapolate far beyond your data's range. Predictions can become absurd. Correlation quickly spots relationships. Regression quantifies and models them. Use these tools wisely to uncover insights and drive real improvements. With practice, you'll turn data into knowledge and make smarter decisions.